Get ready to be amazed, because recent discoveries about the universe are set to challenge everything we thought we knew. Scientists are now questioning the idea that the universe has a definite age and are rethinking the role of dark energy in its accelerating expansion. Instead, they believe something even more mysterious is at play. Groundbreaking observations from the James Webb Space Telescope are uncovering strange and unexpected secrets of the cosmos. The astonishing structures captured in Webb's latest images have left astronomers around the world stunned, reshaping our understanding of the universe itself. I don't believe in any religion, I've said so, and in that sense, I'm an atheist. However, I would say that there is something going on which might resonate with a religious perspective. A few months ago, some of the world's leading cosmologists met at the Royal Society in London to ask the question, what if our fundamental assumptions about the universe are wrong? The meeting was held because many high-level astronomical observations have challenged the traditional cosmological model. According to Professor Subir Sarar, a cosmologist at the University of Oxford and co-organizer of the meeting, we are in cosmology using a model that was first formulated in 1922. We have great data, but the theoretical basis is past its sell-by date. More and more people are saying the same thing, and these are respected astronomers. What he really wants to say is that for centuries, people thought the universe was static or unchanging. But in the 20th century, scientists discovered that the universe is actually expanding. Galaxies are moving away from each other. The big question was whether this expansion would slow down over time because of gravity pulling everything back together. Now here's where things got surprising. When scientists studied distant exploding stars, which provided a more reliable way to measure how the universe is expanding, they expected to find that the expansion was slowing down over time, similar to how a ball thrown into the air slows down as gravity pulls it back. Instead, they found the opposite. The universe's expansion was speeding up. This discovery shocked everyone and completely changed how we think about the universe. To explain it, scientists proposed that a mysterious force called dark energy is pushing galaxies apart, working against gravity. Dark energy makes up about 70% of the universe and is still one of the biggest mysteries in science. All of this comes together, along with ordinary matter, to form what we call the lambda cold dark matter model. Using this expanding universe model, scientists have also found out the age of the universe. It's like rewinding the clock. If the universe is expanding now, scientists calculate how long it would take to shrink everything back to a single point, and they discovered that the universe is about 13.8 billion years old. But the problem is that this model uses a simplified equation that assumes the whole universe is smooth and expands at the same speed everywhere. On the other hand, new images from the Webb telescope revealed large galactic filament structures separated by vast voids, emptier than we can comprehend. Also, previous observations of 1.5 million quasars showed that there are about 0.5% more quasars on one side of the sky than on the other. This suggests that the distribution of matter in the universe is not the same everywhere, and the universe is full of these giant galactic filaments and cosmic voids. However, our standard cosmological models, timescape cosmology, do not support the existence of such massive voids and cosmic structures. This is a serious problem with our cosmological model, and the new discoveries from the Webb telescope make it even more difficult for the standard model to survive. However, to explain all these mysteries, scientists have recently proposed a new model of the universe named timescape cosmology. In this model, scientists highlight the significant influence of massive cosmic voids and structures on the nature of time. They propose that time flows faster in regions of space with a high concentration of matter. For instance, an atomic clock situated within a galaxy might tick up to a third slower compared to an identical clock positioned in the middle of a vast empty void. Now think about this. Over the vast time scale of the universe is about 13.8 billion years old, but in regions with little matter, like cosmic voids, time has been passing faster. So, billions of additional years may have passed in these voids compared to the matter-rich regions. This means that the universe doesn't have a single unified age as we often imagine. Instead, the age of the universe could vary depending on where you are. The age of the universe may be greater in the cosmic void than in a denser region of space. Here's where it gets even more fascinating. Since so much more time has passed in the voids, these regions have experienced more cosmological expansion. In simple terms, the universe has been stretching more in these less dense areas. If you're looking at an object on the far side of a void, it would appear to be moving away from you much faster than an object on the near side of the void. This is because the space within the void has expanded more over time. Now, imagine this effect across the entire universe. Over time, the voids become a larger and larger part of the cosmos because they are expanding more rapidly. As a result, when we observe the universe, it creates the illusion that the overall expansion is accelerating. But in this model, there's no need to introduce dark energy. Instead, the faster expansion in the voids naturally accounts for what we see. In 2017, astronomers from the University of Canterbury in New Zealand tested timescape cosmology against observations and found that it was a slightly better fit than lambda CDM to explain cosmic expansion. What's even more fascinating is that scientists now suspect our Milky Way galaxy might actually be located within a cosmic void. Imagine floating in a vast empty ocean where the closest sign of life is billions of light years away. This might sound like science fiction, but it could be our reality. For years, astronomers have wondered if our Milky Way galaxy is located near the center of an enormous cosmic void, but for decades, they were unsure about it. However, new images from the James Webb Space Telescope suggest that we are indeed inside a gigantic cosmic void. A recent study suggests that our Milky Way galaxy might actually be located in the center of a supervoid, an enormous empty region in space about 2 billion light-years across. Scientists believe that the presence of a supervoid could help solve one of the biggest mysteries in cosmology, the Hubble tension. Hubble tension refers to a puzzling problem where different methods of measuring the universe's expansion give different results. A new study led by scientists Sergei Mazurenko, Indranil Bank, Pavel Kupa, and Moritz Hasselbauer tries to address this problem. They looked at something called the Keenan-Barger C or KBC supervoid, a massive region in space that has fewer galaxies than usual, extending up to 300 million parsecs. This area is a sort of cosmic void, and it creates a unique problem for the standard model of the universe. However, observations of the KBC supervoid don't match what this model predicts. The researchers focused on two main issues: the Hubble tension and something called bulk flow. Bulk flow refers to the movement of galaxies through space. According to the standard model, galaxies should move at certain speeds. However, new observations show that galaxies in certain areas, especially those near the KBC supervoid, are moving much faster than expected. These fast movements are surprising and do not fit well with the current model of the universe. To solve these problems, the researchers used a new approach. They applied a mathematical model developed by one of the authors, Moritz Hasselbauer, to predict how galaxies should move in the universe. If this model is correct, their findings suggest that if we consider this new model, the discrepancies between the observed speeds of galaxies and the predictions of the lambda CDM model can be explained. In simpler terms, they found a way to make the observations fit better with what we expect to see. Their new model suggested that the Milky Way may exist at the center of a supervoid, like the KBC supervoid. Researchers said if our Milky Way galaxy is living inside a supervoid, you're going to see things being pulled away from you towards the more dense regions of the universe. So, if you're sitting in this void, your surroundings expand faster than the rest of the universe. From this vantage point, observers would calculate a higher rate of expansion compared to what they find in the distant early universe, like they do now. What we understand so far is that the timescape model of the universe provides insights into how massive cosmic structures and vast cosmic voids can explain the universe's mysteries, all without relying on the concept of dark energy. Well, that's all for today. Hope you guys enjoyed it. Before you go, don't forget to share your thoughts about this discovery in the comments. Thanks.